Hi, so this is Mary Julian, and I wanted to go over my project too. So I created a way to set up meshes using bilinear and Hermitian transformations. I also do a perspective style transformation. So just like project one, it is based in C++. So you compile the code with running mate, and this does require GTK as well as G++ to compile C++ code. I believe this also works for Macs and Windows, but I haven't tested that. You run the code with just /Hermitian manipulation. It'll launch, and by pressing any part of the screen, we'll create the initial surface. I will go ahead and expand that. So the first mode of creating the mesh I implemented was the bilinear transformation. So you can see that we start with these four boundary lines with our grid points, and you can move the points to any position you'd like, and that will change how the graph appears. So you can have cool perspective changes. You get a nice even mesh. The grid points, I chose 10 grid points in each boundary, and that can be modified. That could also be a control that I give to the user. I just have it as a constant right now in the code. But I implemented this first since it was a little bit easier than the other ways, and it got the grid code working. So each point is linked to the next point. So if you look at the boundaries, this point will reference the next one in the list, and then the boundaries create a parametric line drawing to the next point. And while it's creating the curve to the next point, it will set up all of these grid points. So at the intervals that have been set, it creates a grid point. And then each grid point will go through once the boundary is created and set up its list. So each grid point also has a next in the list, and they'll create their points there too. I'll show you that in the code when I get there. But yeah, this is the bilinear transformation using just line drawing functions. The next would be the Hermitian. Actually, let's go perspective next. So this is, it uses these 2 points, and then we'll create a boundary based on the intersections between the rays that come off of these points. And by changing the red points, you can change how the rays will intersect and create the grid. Right now, the only points that you can change are these red ones, where it would be nice if I could change also the blue points in the UI. Yeah, but the main part of this project was the Hermitian mesh creation with Coons patching. So you can see that we get the same initial boundaries as the linear instance, but in this case, you can also change the vectors. And you can see that each boundary is a Hermitian curve that's dependent on the 12 points. So, well, 4 points and 8 vectors, 12 total variables. And the user can change them and create kind of cool curves, kind of cool surfaces. And if you look at the images folder, I have a couple examples of curves that I've created, or really surfaces that I've created. Overlapping points, you can see it becoming kind of a bowl shape. If you wanted one point to be, or one line to be linear, you can just set the vectors facing each other so that now this line is more aligned. But yeah, you can create cool shapes. And the idea behind this is this could become the basis of a picture transformation. So using this mesh and how the points are fixed either through most likely forward transformation of or forward warping of a picture. A surface like this could become a good basis for a image warping. And if you notice, each point in the grid is connected just via a line. So I do linear interpretation between two lines or between 2 points to create a line. So although the boundaries are a curve, the inner points are purely linear. Square or section that's not a outside section could be a backwards transformation. So you could take this section and use backward transformation to get the warped section. What would need to be forward would probably be the boundary spots, just since the boundary curves are legitimate curves. So this is not, these boundary blocks are not pure linear. So it could become a basis for that kind of warping. Another interesting application might be creating a normal map from this. So given that we have the vectors from the lines of these grids, we could set up a normal map. The boundaries could also become boundaries for a caustic array reflection. That could also be cool. So a couple ideas for project 3, maybe. Yeah, so that is the UI and showing you the curves that are created. Any image, just like project 1, any image that you can create can be saved. I'll save it to my images folder. And these are all of the images that I've gone ahead and created. But if we just say example, that will save your image. That's the same as project 1. So if and right now the images save with the control points. My plan is for project 3 that while I'm saving an image, I'll remove the control points so that you get a nicer PNG file. Right now it saves with controls as well. So if we go into the code, I'll point out a couple of the changes that have been made since project 1, where for point data, I've added this linear curve function. So this is the math that's required to create a line between 2 points. And since I'm not using vectors, I have to split out between X and Y. But you can see it's still that I'm using a parametric function where we come up with this T value. And then from T, we'll get the point and each point along the line. You can also see that I've this grid count determines how many of those green points to create along the boundary line, where at each threshold, it will add that position to the list of grid points. Create harm curve is the same. That's the Hermatian math to create the boundary line. A new class that's been added is this grid point class. Obviously, that's the green points and the lines connecting the green points to create the grid. And I've added 3 different transformation functions. So the first would be this bilinear transformation, which just is the same math that was done on the slides, where we calculate the U and V, and then based on the adjusted points of those corners, it sets the new position. And then for Hermatian, I've used this, the Kuhn's patch, so it creates U and V, and then based on the math described in class, it will create the similar new X and Y. Oh, speaking about math, let me pull up the code again. So speaking about math, let me pull up the code again. And if I go to the Hermatian, you can see that I choose, so say we're manipulating this point. F0 of x would be, we find as this point. F1 of x would be this point. G0 of x is this point here, and then G1 of x, or G1 of y would be this point. So we use the shifted points that are along the lines and not the corners themselves. Just as a note there. Right. And then these are the corners. So this would be the grid points that are getting changed, and then these are the corner points. So we do need both. Yeah, and these are link lists. So we go along the point, and if next, we'll follow along the curve. So this was my project too. Thanks for watching. I hope you enjoyed this.